Okay, so now you're looking at this example and you're thinking to yourself, uh-oh, now we've got a whole lot of complicated things going on in all of this. Well, yes and no. Because we've actually got an equation of this form. And one of the things that we learned earlier about this particular property was that, well, it turns out anytime the logarithm base b of u is equal to the logarithm base b of v, then it must be that u is equal to v, and that is because logarithms are one-to-one functions. So we can't get two different values of u and v for the same output value of the logarithm. So what do we do with that? Well, it means that if I have an equation like this one, I can take advantage of some of my properties that we talked about over here. If you remember these ones. Oops, I want to get my properties right here, and I'm just going to copy this over. And let's go to our next slide right here. And let's take advantage of these properties right here if we can. My mouse doesn't want to work with me here. Here we go. Okay, very nice. Okay, so let's take advantage of these properties. Look at what we've got on the left-hand side of this equation. The natural log of x plus 3 plus the natural logarithm of x minus 2. I can simplify. So that's exactly what I want to do. I want to simplify using my properties. That does say simplify, trust me. So what do? I'm going to have the natural logarithm of the quantity x plus 3 times x minus 2, whatever that turns out to be, right? So all these things are in my logarithm right here. On the right-hand side, I've got 2 times the natural logarithm of x. Well, guess what rule that is? Right? So we can take that multiplier of 2 and let's move it back to the exponent position. We get the natural logarithm of x squared. Yes, now we've got a property that we can use right here. This equation now says that, well, if the quantity x plus 3 times x minus 2 is set equal to x squared, we will have found the value or values of x that make this equation true. So we should go ahead and carry out our algebra now. So let's multiply together x plus 3 times x minus 2. We're going to get x squared plus 3x minus 2x minus 6 is equal to x squared, which is to say that x squared plus x minus 6 is equal to x squared. Now if we gather our like terms by subtracting x squared from both sides, we get x minus 6 is equal to 0. So in other words, we have a solution of x equals 6. And if we look at our equation right here, right, we substitute in x equals 6 into our solution to check it. Well, certainly, taking the natural logarithm of 6 plus 3 and the natural logarithm of 6 minus 2 should hopefully produce for us 2 times the natural logarithm of 6, whatever that happens to be. But in this case, it doesn't really matter because our logarithms are defined. Right, so the logarithm of 9 plus the logarithm of 4 should equal the logarithm of 2 times the natural logarithm of 6. Well, that's actually the same as the natural logarithm of 36, 6 squared. And we could take advantage of one of our properties up here to verify that for ourselves. But in this case, that works. So we do have a solution right here at x equals 6.